How do we do this with a micropore system? Well, that's a pretty simple picture. We're running a buffer as our continuous phase. Our dispersed phase is a lipid or whatever you might want to be. This is a 316 stainless steel device. What we would call a membrane, what most people are used to, membrane, you would conjure up a concept, but that's a stainless steel membrane in there. They've got super tiny holes. We squirt the liquid in through those holes into the continuous phase in laminar flow. We create and then a precipitation to occur, and we get our particles out the other end. Pretty simple, lots of engineering, right? But we can do controlled release, and we can change the conditions. We can do all those good things which we would do in a microfluidic situation. We can increase flow rates, we can change the flow ratio, we can do all sorts of things and get different size particles for whatever job you might want to do. But the most important thing about this is we can scale it. The little system which we've got out on the bench out there, it's got this tiny little mixer, it's called the Mini. And that mixer, we can squirt out samples at 200 microliters. And the same thing can do 20 litres an hour. Or we make it a bit longer, we go up to 200 litres an hour. Add a few of them together, we're sitting at something in the order of 800 litres an hour. Add more, 1,500 litres an hour. That's a shite load of RNA, I would imagine. All right? And then dose scenarios, that's an empirically calculated thing, I've not done. The Mini one, by the way, there's one where there's the AXF4. I'll be going to see this in January in the UK. That's for a 1 billion dose facility in a country just north of Australia. And there's the Mini one, which is actually, well, that will be going to a CMO in Australia very shortly. First GMP nanoparticle production facility in Australia. I'll let you know when it happens. God help me, I'll let you know. All right, so what we're going to do is we're going to look at some systems. There's a bunch of them. That's what they sort of look like when they're made real. What do they do? Well, they make nanoparticles in varying forms. The bonus about this is not a one-size-fits-all. Pick a product and make it work for your application. Tell us what you want. We'll make it. We'll design it. Particularly when we move to GMP side of things, it's completely designed to your application. Yeah, it does it. It does it again and again and again. It gives you the same results over and over. It's boring. It just keeps doing the same crap every day. All right? The encapsulation efficiencies, well, they're up there. We're sitting at about 97, 98%. That's not my data. That's from Strathclyde University. Thank you very much, Yvonne Perry. Good name dropping. There we go. So we've done small stuff. Let's go to the big stuff. Well, I'm not going to show you a picture of it, but that will give you an indication of what we can do. And as I said, the Mini will be in Australia very soon. When you want to know how we are approaching this, or what we do, we've got all those things which process engineering sort of people types like CIP, SIP. The next slide. What I'm about to show you hasn't been made yet, but we're working on it. It might alter your world a bit. I think it will, given the amount of talks which quote this sort of stuff. Okay, so imagine we make the formulation down the bottom left-hand corner there. When we squirt it up the top a bit, we put it into a dilution phase. That dilution's pretty good. We can actually stabilize our particles. That's pretty much what we all want to do. Then we run it through. Imagine a world where we can do a single pass diafiltration. This technology has the capacity to do this. We're just tuning it. We might take a few hours out of the production. Okay? run it through a sterile filtration, and to fill the finish. That gives us a change in that diagram, which we referred to earlier. All right, what do? We have got control process stuff. We can do all those sorts of things. We added to it. Why do we do this? Well, not only can we speed up and change the way that we actually make nanomedicines, no matter which way, whatever you want to do, but we can do stuff like this. This is a project that Michael Paul's working with CEPI on at the moment. That's a 40-foot container. Nearly all the pieces of the puzzle are done, where we can just drop it as a continuous pass-through for full vaccination. Drop that into Nairobi Airport, thank you very much, and make it work for those people. You want to play? Give me a call. Just have a chat to me. Scan that code. I checked it last night, it did work last night, so hopefully it's a good thing. We'll get your system, we'll get your product, we'll take it to you, we'll see what we can do to assist you. Okay? And it comes in a big magic box. So the magic is actually in the membrane. And I hope I'm on time. Thank you. Wait, there is more.